There is a silence that sits at the very edge of our understanding, a quiet boundary where the known world dissolves into shadow. Tonight, we are going to journey toward that shadow. We are going to drift away from the familiar lights of our cities, away from the solid ground beneath our feet, and float outward into the deep, velvet expanse of the cosmos. As we move through this darkness, passing the glowing islands of distant galaxies and the faint, dusty ribbons of nebulas, we are looking for a specific kind of darkness. It is not merely the absence of light, but a profound twisting of space itself, a place where gravity pulls so intensely that reality begins to fold inward. We are traveling toward the event horizon of a black hole. But as we approach this silent giant, hanging in the void like a tear in the fabric of the night, we must ask a question that shifts the very ground of our perception. It is a question that has kept astronomers and physicists awake in the quiet hours of the morning, scribbling equations that refuse to resolve. We usually imagine ourselves as explorers, looking at these objects from the outside, safely observing the monsters of the deep from the shore of a calm island. But what if that perspective is an illusion? What if we are not looking at the abyss from a distance? What if the abyss is already all around us? What if the universe we call home, with its billions of galaxies and its stretching horizons, is actually the interior of a black hole? To understand this possibility, we must first slow down and understand the nature of the black hole itself. We need to strip away the violent imagery of destruction often found in movies and look instead at the elegant, quiet geometry that defines them. In the language of general relativity, a black hole is not simply a vacuum cleaner sucking up debris. It is a place where the river of space flows so fast that it outpaces light. Imagine a wide, slow-moving river flowing toward a waterfall. If you are swimming far upstream, the current is gentle. You can swim against it. You can send a signal to a friend on the shore. But as you get closer to the edge, the water speeds up. There comes a specific point, an invisible line in the water, where the speed of the current exceeds the speed at which you can swim. Once you cross that line, no matter how hard you struggle, you will be carried over the edge. In astrophysics, that line is the event horizon. It is the point of no return. It is the defining feature of a black hole. It is a spherical boundary wrapping around a dense core, a shell of silence. Anything that crosses this threshold, be it a star, a planet, a wandering astronaut, or a single photon of light, is lost to the outside universe forever. From the perspective of someone watching from far away, the light from an object falling in would grow dimmer and redder until it simply faded into nothingness, frozen in time at the very brink of the hole. But here lies the first clue to our great mystery. When we look out at our own universe, we see a similar boundary. We look into the night sky and see stars, galaxies, and the fading glow of the early cosmos. But we cannot see forever. There is a limit to our vision, a cosmic horizon. Because the universe has a finite age and because the speed of light is finite, there is a distance beyond which we cannot see. Light from those distant regions has not had enough time to reach us since the beginning of time. And because the universe is expanding, carrying those distant regions away from us faster than light can travel, we will never see them. We are trapped in a bubble of light, surrounded by an unreachable beyond. Is it a coincidence that we live inside a sphere we cannot escape, just as matter inside a black hole resides inside a sphere it cannot escape? Physicists have begun to wonder if these two horizons, The event horizon of a black hole and the cosmological horizon of our universe are mathematically related. When we study the equations that describe the universe, we find that they bear a haunting resemblance to the equations that describe the interior of a black hole. It is as if we are living in a reverse image. In a black hole, matter collapses inward. In our universe, space expands outward. But the geometry, the way space and time curve and lock together, suggests they might be two sides of the same coin. Let us drift deeper into this idea by considering the nature of density. When we think of black holes, we usually think of density so extreme it crushes atoms. We imagine a star collapsing into a point smaller than a city, then smaller than a pinhead. And for the black holes formed by dying stars, this is true. They are incredibly dense, violent places. But the math of gravity offers a surprising loophole, one that is crucial to the theory that we inhabit such a world. The larger a black hole becomes, the less dense it needs to be to form. This seems counterintuitive, so let us visualize it. To make a black hole, you need to pack a certain amount of mass into a certain amount of space. This is defined by the Schwarzschild radius. If you wanted to turn the Earth into a black hole, you would have to crush the entire planet down to the size of a marble. That requires unimaginable density. But if you wanted to turn the entire solar system into a black hole, you wouldn't need to crush the matter nearly as much. The required density drops. Now, imagine a black hole the size of a galaxy. Its average density would be less than that of the air you are breathing right now. And if you go even larger, to a black hole the size of our observable universe, the density required to create an event horizon matches the average density of the universe we see around us. This is a staggering realization. If you take all the stars, all the gas, all the dark matter, and all the energy in the visible cosmos, and calculate the size of the black hole that mass would create, the answer is almost exactly the size of the observable universe. It suggests that we do not need to be crushed into a singularity to be inside a black hole. We could be floating comfortably inside a supermassive, ultra-low density event horizon, completely unaware that we are trapped. The air in your room, the water in the oceans, the drifting clouds, everything feels normal because the scale is so vast. The tidal forces that would normally rip a traveler apart near a small black hole are, on this scale, so gentle they are undetectable. We are like microscopic life forms floating in a single drop of water, unaware that the drop is falling through the air. As we float here in the safety of our imagination, looking at this vast connection, we must ask, what does it mean to be inside? In our daily lives, being inside something implies confinement. It implies walls, a ceiling, a floor. But in the four-dimensional geometry of relativity, inside is a matter of time as much as space. Inside a black hole, space and time switch roles. This is one of the most disorienting and beautiful concepts in physics. Outside the hole, you have the freedom to move in any direction in space, left, right, up, down, but you are forced by the flow of time to move forward toward the future. You cannot stop time, and you cannot go back. Once you cross the event horizon, the geometry flips. The radial direction, the path leading inward toward the center, becomes your future. You can no longer move out any more than you can move yesterday. The center of the black hole, the singularity, is no longer a place in space. It becomes a moment in time. It is a future event that is waiting for you. And just as we, in our universe, are helplessly dragged forward in time toward tomorrow. Matter inside a black hole is helplessly dragged toward the center. Does this sensation of inevitable forward motion feel familiar? We are all travelers on a river of time we cannot control. We are born, the universe expands, and we drift toward an unknown future. The expansion of our universe could be interpreted as the result of this geometry. What we perceive as the expansion of space might actually be the sensation of falling. We might be falling toward a destination we cannot see, and the expansion we measure is simply the geometry of the black hole guiding us along our timeline. This perspective shifts the nature of our existence from one of randomness to one of profound order. If we are inside a black hole, then our universe is not a chaotic accident, but a contained vessel. It has boundaries, even if we cannot touch them. It has a parent, a source from which it came. It suggests that our reality is nested within a larger reality, a concept that ancient philosophers whispered about long before mathematics could describe it. They spoke of worlds within worlds, of skies above skies. Now, general relativity offers us a blueprint for how such a structure could exist. Let us pause and consider the darkness again. When we look at a black hole from the outside, it appears black because it absorbs all light. But if you were inside, looking around, would it be dark? Not necessarily. If the black hole were large enough, like the one we might be inhabiting, light would still travel between the stars inside. Galaxies would still form. Planets would still cool and orbit their suns. Life would still rise from the oceans and look up in wonder. The interior of a black hole is not a dungeon. It is a sanctuary. It is a pocket of space-time pinched off from the rest of the cosmos, allowing a new history to unfold within its shelter. The event horizon, that silent sphere, acts as a filter. It allows things to enter, but forbids them from leaving. In this way, a black hole is a collector. It gathers matter and energy from the outside universe, gas clouds, stray asteroids, light, and adds them to the interior world. If we are indeed inside such a place, then perhaps our universe is growing. Every time our parent black hole swallows a star in the higher universe, our own cosmos might gain mass. What we perceive as the fundamental constants of nature might be influenced by what is falling into our horizon from a place we can never visit. This thought brings a sense of humility. We often think of the Big Bang as the very beginning of everything, the moment when the clock started ticking. But if we are inside a black hole, the Big Bang was not the beginning of reality. It was merely the beginning of our reality. It was the moment the event horizon formed, the moment our bubble of space-time snapped shut and began its independent life. There was something before. There is something outside. We are protected from it, shielded by the horizon, but we are intimately connected to it. The silence of the event horizon is not an empty silence. It is a silence full of information, full of history. It separates the here from the there in the most absolute way possible. And yet, this separation allows for existence. Without the shelter of the horizon, without that protective curve of gravity, perhaps the delicate conditions for life could never have arisen. We might be like pearls forming inside the shell of a cosmic oyster, hidden away in the dark so that we can shine. As we drift through this section of our journey, let the idea settle over you like a warm blanket. The darkness of space is not a void. It is a vessel. The gravity that holds your feet to the floor is the same force that might be holding our entire universe together in the embrace of a singularity we call the future. We are navigating a great dark ocean, but we are not adrift. We are enclosed, we are held. The boundary of the known is not the end of the story. It is simply the threshold where the geometry changes. We have stood at the edge of the event horizon and looked at the similarities between the abyss and our home. We have weighed the universe and found it matches the ghost of a black hole. We have felt the flow of time and recognized it as the pull of gravity. But if we are inside, what lies at the center? If every black hole leads to a singularity, a point of infinite density where math breaks down, then where is our singularity? Did we leave it behind in the past, or is it waiting for us in the future? To understand this, we must travel back to the moment of creation itself. We must look at the explosion that started it all and see if it was, in fact, a collapse. We must turn our gaze from the edge of the universe to its fiery beginning. For in the strange mirror of physics, an explosion and an implosion can look exactly the same, depending on where you are standing. As we prepare to move deeper into this mystery, let us carry with us the realization that the night sky is not a ceiling, but a vast, curving hull of a ship carrying us through a much larger, stranger sea. Let us now turn our gaze backward. We leave the silent boundary of the event horizon behind us for a moment and look toward the very center of our history. If the horizon is the edge of our cage, then the Big Bang is the memory of how we arrived here. It is the defining moment of cosmology, the single point in time when the clock began to tick, when space began to stretch, and when the cold, vast emptiness we see today was compressed into a blindingly hot, infinitely dense speck of pure energy. When scientists describe this moment, they use a specific word. They call it a singularity. It is a mathematical term for a place where the rules of the game stop working. At a singularity, density becomes infinite. Temperature becomes infinite. The smooth, predictable curves of space-time form a sharp point, like the tip of a cone. For decades, this singularity at the beginning of time has been a source of frustration. It is a wall we cannot see behind. We can trace the history of the universe back to a fraction of a second after the explosion, but we cannot reach the moment itself. The equations simply break down. But there is another place in the universe where we find this exact same breakdown. There is another place where gravity creates a singularity, where density spikes to infinity, and where space-time punctures. It is the heart of a black hole. This similarity is not a coincidence. It is a reflection. It is as if the universe is holding up a mirror. In one reflection, we see a black hole, a massive object collapsing inward under its own weight, crushing matter down to a point. In the other reflection, we see the Big Bang, a point of matter exploding outward, expanding to become a universe. One is an implosion, the other is an explosion. One is a crash, the other is a launch. But mathematically, they are almost identical. They are just playing the movie in different directions. This leads us to a profound hypothesis, one that marries the death of stars with the birth of worlds. What if the singularity of a black hole and the singularity of the Big Bang are actually the same thing, seen from two different perspectives? Imagine for a moment that you are observing a massive star in a distant, older universe. Let us call it the parent universe. You watch as this star burns through the last of its fuel. It fights against the crushing grip of gravity for millions of years, pushing outward with the heat of its nuclear fusion. But eventually, the fuel runs out. The fire dies. Gravity, patient and relentless, finally wins. The star collapses. In a matter of seconds, an object millions of kilometers wide crumples down into a point smaller than an atom. From your perspective in the parent universe, the star has disappeared. It has vanished behind an event horizon, leaving a black hole in its wake. To you, it looks like a dead end, a closure, a period at the end of a sentence. But now, imagine you are the matter inside that collapsing star. You are being crushed, yes, but you are also falling. You are falling through the event horizon, tumbling toward the center. As you reach the singularity, the laws of physics as we know them shift. Instead of hitting a solid wall and ceasing to exist, something extraordinary happens. The intense gravity twists space and time so violently that down becomes out. The crushing force of the collapse reaches a quantum limit, a maximum density that nature allows, and then it rebounds. This rebound is what we, on the inside, call the Big Bang. From the outside, it was a collapse. From the inside, it is an expansion. The matter from that dying star in the parent universe pushes outward into a new dimension, creating a new bubble of space-time. It inflates rapidly, cooling as it spreads, turning that intense, knotted energy of the singularity into quarks, electrons, and eventually hydrogen. The death of the star was not an end, it was a transfer. It was a seed pod bursting open to scatter its contents into a new field. This idea that our Big Bang is the white hole resulting from a black hole in another universe solves many of the problems that plague cosmologists. It explains why the Big Bang happened at all. In traditional cosmology, the Big Bang is a mystery. It simply occurs without cause or reason. It is an effect without a cause. But in the black hole cosmology, the cause is clear. Our universe was born because a star died somewhere else. We are the afterlife of a stellar giant. It creates a beautiful, continuous chain of cause and effect. It suggests that universes are not isolated islands that appear from nowhere, but are instead part of a great, breathing lineage. Just as living things on Earth are born from parents, universes are born from parents. The singularity is the umbilical cord. It is the narrow, intense channel through which matter and energy flow from one reality to the next. When we look at the early universe, we see evidence that supports this. We see a cosmos that was incredibly uniform, hot, and smooth. This is exactly what you would expect if our universe were formed from the churned, homogenized matter of a stellar collapse. The intense gravity of the black hole would act like a blender, mixing everything together until it was perfectly even before spewing it out into our reality. The cosmic microwave background radiation, that faint static of heat left over from the beginning, is incredibly smooth in every direction we look. This smoothness has always been a puzzle, but if we are the interior of a black hole, it is a natural consequence of our birth. This perspective also changes how we feel about the flow of time. We often ask, what force keeps the universe in motion? Why does time march forward? Why does the universe expand? If we are the interior of a black hole, the expansion of the universe is simply the momentum of the collapse carrying over. The star fell inward with tremendous speed. That speed is now our expansion. We are still riding the shockwave of that ancient implosion. The reason time moves forward is that we are moving away from the singularity of our birth, drifting toward the cooling, quiet future. There is a deep, resonant poetry in this model. It suggests that destruction is never truly destruction. In our human lives, we fear the end. We fear the dark, the cold, the cessation of being. But on the cosmic scale, the most violent event imaginable, the total collapse of a sun, is merely the opening of a door. What looks like death from one side looks like birth from the other. As we drift through this section of the cosmos, looking at the faint red light of the oldest galaxies, we can imagine them as the first debris from that great collision. They are the shrapnel of creation. And we, sitting here on our small blue world, are made of that same debris. The atoms in your hand, the oxygen in your lungs, the iron in your blood. If this theory holds true, all of it once existed in the heart of a giant star in a universe we can never see. We have traveled through the eye of the needle to be here. Let us consider the nature of the bounce a little longer. In quantum mechanics, there is a principle that things do not like to be pinned down. If you try to squeeze a particle into a space that is too small, it vibrates with intense energy. It pushes back. This is called quantum pressure. When a star collapses, gravity tries to squeeze it into a space of zero size. But quantum mechanics says no. At the very last moment, when the density reaches the Planck scale, the smallest possible unit of space, the material snaps back. Imagine a rubber ball dropped from a great height. It falls faster and faster, hitting the ground with immense force. For a split second, the ball is compressed, flattened against the pavement. That moment of maximum compression is the singularity. But the ball does not stay flattened. The energy is stored, and then it releases. The ball bounces upward. If you were a microscopic creature living on the surface of that ball, you would feel a sudden, rapid expansion of the rubber beneath your feet. You would perceive a big bang. Our universe is that ball expanding after the bounce. We are currently in the upward phase, the expansion phase. We are flying apart because we were thrown by gravity itself. This theory also touches on the concept of the Einstein-Rosen bridge, commonly known as a wormhole. In the early days of relativity, physicists realized that the mathematics of a black hole didn't just stop at the center. The equations suggested that the funnel of gravity could open up again on the other side. A black hole could be a tunnel. For a long time, this was considered just a quirk of the math, a fantasy for science fiction writers. But if we live inside a black hole, then the Einstein-Rosen bridge is our reality. We are in the throat of the wormhole. The universe we see, with its billions of light years of depth, might be the interior of that tunnel, stretching out as it grows. It is a dizzying thought. It implies that space is not a flat stage, but a convoluted, folded structure. We are hidden away in a pocket, and this pocket is vast. It is difficult for the human mind to reconcile the idea of being inside something with the immense scale of the sky above us. We look up and see infinity. How can infinity be inside a hole? The answer lies in the warping of space. Gravity bends rulers. It stretches distances. Near a singularity, space is stretched to such an extreme degree that a small area on the outside becomes a vast volume on the inside. It is like the TARDIS from Doctor Who. Bigger on the inside than the outside, a black hole in a parent universe might be only a few kilometers wide to an outside observer. But because of the way gravity distorts the geometry, the interior of that hole could contain a universe billions of light years across. We fit because space is pliable. Space is not a rigid box. It is a fabric that can be crumpled, stretched, and blown up like a balloon. This realization brings a strange comfort. We often feel small in the universe, insignificant specks on a lonely rock. But if we are the children of a black hole, then we are the result of a spectacular cosmic perseverance. It took a massive star living a full life, burning bright and dying hard, to create the conditions for us to exist. We are the legacy of a giant. And what of the singularity itself? We usually fear it as a point of destruction. But in this light, the singularity is the engine of creation. It is the forge. It is the place where the old rules are melted down and new rules are cast. The laws of physics that govern our lives, the strength of gravity, the charge of the electron, the speed of light, were perhaps decided in that fiery moment of the bounce. We are living in a reality tuned by the collapse. As we end this chapter of our journey, floating in the afterglow of the Big Bang, we must ask ourselves if our universe is a projection of this event. Is it real, or is it a shadow? If we are living in the echo of a collapse, are we solid? The ground beneath your feet feels firm. The air feels real. But physics suggests that this solidity might be a trick of perspective. We might be living on the surface of a bubble, or perhaps we are a hologram projected from the edge of the horizon. This leads us to our next great question. If the information of the star was lost when it fell into the hole, where did it go? Did it vanish? Or is it painted on the walls of our universe, projecting the reality we see today? We have explored the fire of the beginning. Now, we must turn our eyes to the walls of the cave. We must explore the holographic principle. We have journeyed from the quiet, invisible boundary of the event horizon to the fiery, explosive birth of the cosmos. We have seen how the collapse of a star in a distant place could have been the seed for everything we know, turning our universe into a vast, expanding interior of a black hole. But now, we must turn our attention to the nature of the reality that fills this space. If we are indeed living inside a cosmic vessel enclosed by a sphere of gravity, we must ask ourselves what that boundary actually does. Is it simply a wall, a fence that marks the end of our property? Or is it something far more active, far more strange? To answer this, we must grapple with one of the most unsettling ideas in modern physics. It is an idea that challenges the solidity of the ground beneath your feet and the very substance of your own body. It suggests that the three-dimensional world we navigate, the depth of the oceans, the height of the mountains, the vast distance between the stars, might be an elaborate illusion. It suggests that we are not solid objects floating in a deep void, but rather we are projections. We might be a hologram, shimmering into existence from information stored on the distant walls of our universe. This concept, known as the holographic principle, began with a puzzle about trash. Imagine for a moment that you are an astronaut floating near a black hole. In your hands you hold a book. It is a thick encyclopedia containing thousands of pages of information, history, science, poetry. Now, imagine you toss that book toward the black hole. It tumbles through the darkness, crosses the event horizon, and vanishes. From your perspective, the book is gone. But physics asks a deeper question. What happened to the information inside it? According to the fundamental laws of quantum mechanics, information can never be destroyed. You can burn a book, but if you could gather every wisp of smoke and every pile of ash, you could theoretically reconstruct the text. Information is eternal. But a black hole seems to violate this rule. If the book falls into the singularity and is crushed out of existence, the information seems to be erased from the universe. This was a crisis in physics for decades. It threatened to undo our understanding of reality. But then, a solution was found, and it changed everything. Physicists realized that when an object falls into a black hole, its physical body may be lost to the interior, but its information, the mathematical blueprint of what it was, gets plastered onto the surface of the event horizon. Think of it like a sticker being placed on a suitcase. The book is gone, but a two-dimensional imprint of its contents remains scrambled across the outer shell of the whole. The event horizon is not just a boundary. It is a storage device. It is a vast, spherical hard drive preserving the memory of everything that has ever fallen in. Here is where the ground shifts beneath us. If the surface of a black hole contains all the information of the objects inside it, then mathematically, the three-dimensional interior is equivalent to the two-dimensional surface. The volume is just a projection of the shell. And if our universe is the interior of a black hole, as we have hypothesized, then the same logic applies to us. Everything you see around you, the chair you are sitting in, the walls of your room, the stars in the sky, might be a three-dimensional projection of two-dimensional data stored on the cosmological horizon billions of light years away. We are like the images in a cinema. When you watch a movie, you see depth. You see characters moving toward you and away from you. You see landscapes that stretch to the horizon. But if you were to walk up to the screen and touch it, you would feel only a flat surface. The depth is a trick of light and perspective. The reality of the movie is stored on a reel of film in the projection booth, a flat strip of plastic that generates a world. In this cosmic version of the cinema, the film is the boundary of the universe, and we are the movie. This sounds like science fiction, or perhaps a dream, but the mathematics of the universe supports it beautifully. When scientists try to calculate the amount of stuff a region of space can hold, essentially, how much information can be packed into a room, they find that the limit depends not on the volume of the room, but on the surface area of the walls. This is counterintuitive. If you fill a box with marbles, the number of marbles depends on the volume inside. But in the deep physics of space-time, the capacity for reality is defined by the surface area. It is as if the interior volume is merely a reflection of the surface. If we accept this, the sensation of living inside a black hole takes on a ghostly, ethereal quality. We are distinct, solid beings, yet we are connected by invisible threads to the farthest edge of the cosmos. Every movement of your hand, every beat of your heart, every thought that drifts through your mind is actually a shifting of data on the distant horizon. We are puppets of light, dancing to a script written on the walls of the sky. This connection between the edge and the center solves many problems. It explains why gravity is so much weaker than the other forces of nature. Have you ever wondered why a simple fridge magnet can pick up a paperclip against the gravitational pull of the entire Earth? The Earth is massive, yet a tiny magnet defeats it. Gravity is incredibly weak. The holographic principle suggests this is because gravity is not a fundamental force in the 3D space, but a byproduct of the projection. It is a leakage of the information processing happening on the horizon. We feel gravity as a faint echo, a residue of the true reality occurring on the 2D surface. Let us drift deeper into this illusion. If space is a hologram, then it must be pixelated. A photo in a newspaper looks smooth from a distance, but if you bring it close to your eye, you see the dots. A computer screen looks like a continuous image, but with a magnifying glass, you see the pixels. If our universe is a projection, there must be a limit to the resolution of reality. There must be a smallest possible unit of space, a pixel of existence. Scientists call this the Planck length. It is unimaginably small, trillions upon trillions of times smaller than an atom, but it is there. And remarkably, we might be starting to see the blur. In Germany, there is an experiment called GEO 600, a massive detector designed to sense gravitational waves. For years, the detector was plagued by a mysterious noise, a persistent static that the researchers could not eliminate. Some physicists have speculated that this static might be the holographic noise of the universe. It might be the result of the machine reaching the limit of space's resolution. It is possible that we are hearing the hum of the projector. We are seeing the grain of the film. This idea fits perfectly with the black hole universe theory. A black hole is defined by its event horizon, and that horizon is paved with these tiny pixels of information. The larger the black hole, the more pixels it has, and the more complex the universe inside can be. A small black hole might only contain enough data to project a few swirling atoms. But a black hole, the size of our universe, contains enough pixels to project galaxies, nebulas, biological life, and the complex neural architecture of the human brain. We exist because our container is large enough to hold our description. There is a profound philosophical beauty here. We often ask, "Am I real?" The holographic principle answers, yes, but not in the way you think. You are real in the way a song is real. A song can exist as grooves on a vinyl record, as magnetic patterns on a tape, or as digital code in a cloud server. But the song itself is the experience of hearing it. We are the music played by the universe. The real us is the deity on the horizon. The experienced us is the life we are living right now. The separation between the two is an illusion. As we float in this projected cosmos, consider the stability it offers. A projection requires a steady light. If the horizon of our black hole were turbulent or chaotic, our reality would distort and tear. The fact that the laws of physics are constant, that the speed of light does not waver, that atoms hold their shape for billions of years, this speaks to the stability of the container we are in. We are safe inside the shell. The storm of the multiverse might be raging outside, but in here, the image is steady. This perspective also reframes our understanding of connection. In a hologram, every part of the film contains the image of the whole. If you cut a hologram of an apple in half, you don't get half an apple. You get two smaller, complete apples. The information is distributed non-locally. This mirrors a phenomenon in quantum mechanics called entanglement, where two particles, separated by vast distances, seem to know what the other is doing instantly. Einstein called it spooky action at a distance. But in a holographic universe, it isn't spooky at all. The two particles are far apart in the 3D projection, but on the 2D surface where the data lives, they might be right next to each other. The distance between us is a construct. At the fundamental level of the horizon, we are all woven into the same tapestry. So, as we look out at the stars tonight, remember that you are looking at the internal architecture of a vast mind. The universe is processing information. It is calculating the future from the data of the past. And this calculation is what we perceive as the flow of time. We are moving through the story that the horizon is telling. But a story implies an author, or at least a mechanism of creation. If we are living inside a black hole, and if that black hole is projecting a universe capable of life, we must ask, why? Why is the projection so perfect? Why are the laws of physics tuned so precisely to allow for stars to shine and carbon to bond? If the gravitational constant were slightly stronger, stars would burn out in weeks. If it were weaker, they would never ignite. We seem to live in a Goldilocks black hole, one that is just right for existence. Is this luck? Is it a random accident of the cosmic dice? Or is there a deeper process at work? Is it possible that universes, like biological creatures, are subject to evolution? If black holes are the reproductive organs of the cosmos, giving birth to baby universes, then perhaps the laws of physics are traits passed down from parent to child. Perhaps we live in this universe not because it is special, but because it is a survivor. As we prepare to move to the next stage of our inquiry, let us hold on to the image of the hologram. It reminds us that appearance is not essence. It reminds us that the solid walls of our challenges are often just shadows, and that the true substance of reality lies in the hidden connections we cannot see. We are light and information projected into a beautiful, dancing form. And just as life on Earth has evolved to master its environment, perhaps the universe itself has evolved to master the art of existence. Let us now turn our gaze to the mechanism of this evolution. Let us explore the theory of cosmic natural selection and see if the black hole we inhabit is the result of a long, ancient lineage of cosmic ancestors striving toward perfection in the dark. We have floated through the event horizon, witnessed the fiery rebound of the Big Bang, and touched the shimmering, holographic walls of our reality. We have established that we might be living inside a cosmic vessel, a bubble of space-time that was born from the collapse of a star in a distant, unseen realm. But as we look around at the architecture of this vessel, at the swirling galaxies, the burning stars, and the delicate chemistry of life, a new and profound mystery begins to take shape. It is not just how we are here, but why things are the way they are. Why does this black hole interior feel so perfectly designed? If you were to sit down at a control panel that governed the laws of physics, you would be faced with a series of dials. One dial controls the strength of gravity. Another controls the electromagnetic force that holds atoms together. Another determines the mass of an electron, or the speed of light. In our universe, these dials are set to very specific, precise numbers. And here is the unsettling truth. If you were to turn any of these dials even a fraction of a notch to the left or right, the machinery of the universe would grind to a halt. If gravity were slightly stronger, stars would burn through their fuel in a few million years, dying before life ever had a chance to evolve. If gravity were slightly weaker, gas clouds would never condense into stars at all. The universe would remain a cold, dark fog forever. If the electromagnetic force were just a little different, atoms would not bond, and the complex molecules that make up your body, the proteins, the DNA, or the water, could never form. We seem to be living in a Goldilocks universe, where every fundamental constant is tuned to a razor edge of perfection to allow for structure, light, and complexity. For a long time, scientists looked at this precision and called it luck. They called it the anthropic principle, the idea that we see these conditions because if they were any different, we wouldn't be here to see them. It is a logical tautology, true but unsatisfying. It feels like winning the lottery 1 billion times in a row and shrugging it off as coincidence. But the black hole theory offers a different, more organic explanation. It suggests that this precision is not luck. It is a family trait. It is the result of a long ancestral lineage of universes striving for survival. This is the theory of cosmic natural selection. To understand it, we must look at the one process we know that creates complex design out of chaos, evolution. On Earth, we see how life adapts. A moth develops camouflage to hide on a tree bark. A bird develops a beak perfectly shaped to crack a specific nut. This happens not because the moth or the bird chose these traits, but because their ancestors who possessed them survived long enough to reproduce. Nature selects for success. Nature selects for the ability to pass on genes to the next generation. Now, apply this logic to the cosmos. What if universes reproduce? What if they have children? And what if, like biological creatures, they pass on their traits, their laws of physics, to their offspring? We have already identified the reproductive mechanism. It is the black hole. In this framework, a black hole is not a tomb, it is an egg. When a massive star collapses and creates a singularity, it births a baby universe on the other side, expanding out into its own dimension. This means that the fitness of a universe, its success in evolutionary terms, is measured by how many black holes it can create. A universe that creates 0 black holes is sterile. It has no children. Its lineage ends when it dies. But a universe that creates billions of black holes is fecund. It creates billions of offspring, each carrying a variation of its parent's physics. Imagine a primordial universe, billions of generations ago. It might have been a chaotic, short-lived place. Maybe its gravity was too strong, and it collapsed back on itself instantly. It had no children. It was an evolutionary dead end. But somewhere in the multiverse, a universe appeared with just the right balance of forces to allow stars to form. This is the crucial link. To make a black hole, you usually need a massive star to die. Therefore, for a universe to reproduce, it must first be capable of producing stars. This changes everything. The stars we see twinkling in the night sky are not just pretty lights. They are the reproductive organs of our cosmos. They are the factories where the next generation of universes is being prepared. The universe wants to make stars because stars lead to black holes, and black holes lead to survival. And this is why our laws of physics are so finely tuned. We live in a universe that is optimized for star formation. The balance of gravity and expansion, the ratio of matter to energy, it is all calibrated to maximize the production of black holes. We are not the lucky winners of a lottery. We are the citizens of a highly evolved, successful universe that has inherited the best traits from a long line of ancestors. We are living in the peak of cosmic fitness. Let us drift through this family tree for a moment. Imagine the mutations that occur during the bounce. When a star collapses and a new universe is born, the laws of physics might shift slightly. It is like a genetic mutation. Perhaps in the new universe, the electron is a tiny bit heavier. Perhaps the strong nuclear force is a tiny bit weaker. Most of these mutations might be harmful, leading to sterile universes full of empty gas or solid crystals. But occasionally, a mutation occurs that makes the new universe even better at forming stars. It produces even more black holes than its parent. This new variation dominates the population. Over eons of time, the multiverse fills up with universes like ours, universes that are incredibly efficient at building galaxies and collapsing stars. But where do we fit into this? Where does life, consciousness, and the human experience enter this grand cycle of cosmic reproduction? This is the most beautiful part of the theory. It turns out that the conditions required to make a black hole are almost exactly the same as the conditions required to make life. To create a black hole, you need massive stars. To create massive stars, you need a universe that is cool enough for gravity to clump gas together, but hot enough for fusion to ignite. You need a universe where atoms can form. Furthermore, the process of star formation creates the heavy elements. In the fiery hearts of stars, hydrogen is fused into carbon, oxygen, nitrogen, and iron. These are the very elements that make up the dust of the universe. They are the elements that form planets, and they are the elements that form us. You cannot have life without carbon. You cannot have life without the complex chemistry that arises from stellar fusion. So, in a strange twist of fate, life might be a byproduct of the universe's reproductive drive. The cosmos didn't necessarily set out to create humans, or whales, or forests. It set out to create black holes. But the machinery needed to build black holes, stable laws, long-lived stars, complex chemistry, is the exact same machinery that allows life to flourish. We are, in a sense, the moss growing on the engine of creation. We are the passengers on a ship built for a different purpose, but a ship that is perfectly suited to keep us safe and warm. This realization dissolves the loneliness of the anthropic principle. We are not isolated accidents. We are a necessary part of the landscape of a fertile universe. If the universe were hostile to life, it would likely be hostile to stars, and thus it would be hostile to its own reproduction. Life and the cosmos are natural partners, bound together by the laws of selection. As we float here considering this, look at the darkness of space differently. It is not a cold, indifferent void. It is a garden that has been weeding itself for eternity, selecting for the conditions that allow for light, heat, and complexity. The seemingly empty space between galaxies is filled with the potential for the next generation. Every time a supernova explodes, flashing brighter than a galaxy for a few weeks before vanishing, we should not see it as a tragedy. We should see it as a birth. Somewhere, in a dimension we cannot access, a new Big Bang is happening. A new clock is starting. A new story is beginning, written with the ink of our own universe's physics. And what of the variety? Just as evolution on Earth produces a staggering array of life forms, from the blue whale to the microscopic tardigrade, evolution in the multiverse might produce a staggering array of universes. There may be universes with slight variations that we can barely imagine, exotic realms where light travels at different speeds, or where matter forms different kinds of atoms. But they would all share a common ancestry. They would all be related to us. This theory also implies that our universe has a future. It is not a static, dying thing. It is an active participant in a chain of being. As long as stars continue to form and collapse, our universe is fulfilling its purpose. It is passing the torch. And we, the observers, are the witnesses to this continuity. There is a quiet comfort in knowing that the laws of physics are not arbitrary rules imposed from above, but hard-won adaptations acquired over eons of trial and error. The stability of the proton, the bond of the carbon atom, the steady pull of gravity, these are the survival strategies of the cosmos. We can trust them because they have worked for billions of generations. As we digest the scale of this idea, we must ask if our universe is growing, if it is expanding to accommodate the new mass falling in from our parent universe, And if we are creating baby universes of our own, is there a physical sign of this growth? Is there something we can measure in the dark sky that hints at this connection? This brings us to the greatest unsolved mystery in modern cosmology: dark energy. We observe that our universe is not just expanding, it is accelerating. The galaxies are rushing away from each other faster and faster every day. A mysterious, invisible force is pushing the cosmos apart. For years, this has been described as a sinister, unexplained energy inherent to space itself. But in the context of the black hole universe, dark energy might not be a mystery at all. It might be the most direct evidence we have of our location. If we are inside a black hole and that black hole is inside another universe, what happens when our parent black hole swallows something? If a massive cloud of gas falls into the black hole that contains us, the event horizon grows. The volume increases. To us, on the inside, that increase in volume would look exactly like an expansion of space. It would look like the galaxies were being pushed apart by an invisible hand. Could it be that the expansion of our universe is simply the feeding of our parent? Could the acceleration of the galaxies be a sign that our parent universe is rich with matter, raining down nourishment onto our event horizon? It is a thought that turns the abstract mathematics of expansion into a tangible, physical connection. We are growing because we are eating. We are expanding because we are part of a larger, dynamic environment. As we prepare to drift into the next section of our journey, hold on to this feeling of connection. We are not lost in a random void. We are nestled in the womb of a black hole, which itself is floating in a larger universe, which might be part of an even larger lineage. We are the result of an infinite progression of mothers and daughters, a cascade of creation that has refined the very fabric of reality until it was capable of holding you, right here, right now. Let us now turn our attention fully to this mysterious force. Let us explore dark energy not as a monster pushing us apart, but as the breath of the universe itself, signaling its growth and its connection to the outside world. As we continue our drift through this strange and beautiful hypothesis, we find ourselves floating in the vast, open spaces between the galaxies. Until now, we have stayed close to the structures of the universe, the fiery birth of the Big Bang, the shimmering walls of the holographic horizon, and the swirling, reproductive nurseries of the stars. But to understand the next piece of evidence that suggests we are living inside a black hole, we must leave the light behind. We must venture into the deep, cold voids where there is seemingly nothing at all. When you look up at the night sky, it feels static. The constellations appear fixed, anchoring us in a sense of permanence. But this stillness is the greatest illusion of all. We know that the universe is expanding, a fact discovered nearly a century ago. For decades, astronomers believed this expansion was a simple coasting effect, a leftover momentum from the Big Bang, like a car rolling down a highway after the engine has been turned off. They assumed that eventually, the gravity of all the stars and galaxies would act like a brake. They thought the universe would slow down. They thought gravity would win, pulling everything back together in a gentle, big crunch, or perhaps bringing the expansion to a graceful halt. But in the late 1990s, when astronomers looked at distant supernovae, exploding stars that act as cosmic mile markers, they found something that shook the foundations of physics. The universe was not slowing down. It was not tapping the brakes. It was hitting the gas. The galaxies are rushing away from each other faster today than they were yesterday. The expansion is accelerating. Some invisible, unknown agent is stretching the fabric of space, pushing the cosmos apart with a relentless, smooth pressure. Scientists name this mystery dark energy. It is a placeholder name for a shadow we do not understand. And it is not a small anomaly. When we tally up the energy budget of the universe, this dark, expansive force makes up nearly 70% of everything that exists. We are floating in a sea of this invisible power, and for 20 years, we have had no idea where it comes from. But if we view our reality through the lens of a black hole, dark energy is no longer a mystery. It is a mechanic. It is the signature of our container growing. Let us return to the image of our universe as a bubble of space-time enclosed by an event horizon, the interior of a giant black hole. In the world outside our universe, in that parent universe, this black hole is an object with mass. It has gravity, and like all black holes, it feeds. It sits in a galaxy in a higher dimension, surrounded by clouds of gas, wandering stars, and perhaps other dark matter. Now, imagine that in that parent universe, a massive cloud of interstellar gas drifts too close to our black hole. It gets caught in the gravity well. It spirals inward, heating up, glowing bright, until it crosses the event horizon. To an observer on the outside, that matter has disappeared. The black hole has simply grown slightly larger. Its mass has increased. And because the radius of a black hole is directly tied to its mass, its event horizon, the surface area of the sphere, expands. But what happens to the inside? If the shell of our universe grows, the interior volume must grow with it. Space itself must stretch to accommodate the new capacity of the container. To us, living inside the bubble, we would not see the gas cloud falling in. We cannot see through the horizon. We would simply perceive a sudden, smooth stretching of space. We would see our galaxies drifting further apart, not because they are moving through space, but because new space is being created between them. This implies that dark energy is not a force pushing us apart. It is a reaction. It is the physical manifestation of our parent black hole eating dinner. When we observe the expansion of the universe accelerating, we might be witnessing a feeding frenzy in the realm above. Perhaps our parent black hole has drifted into a dense nebula in its own cosmos. As it swallows that fog of higher dimensional matter, our horizon stretches rapidly, and we experience a surge of dark energy. The acceleration we measure is simply the rate of accretion on the outside. We are directly coupled to the metabolism of a monster we can never see. This concept, often called cosmological coupling, transforms our understanding of the void. We tend to think of the empty space between galaxies as nothing. But in this theory, that empty space is the fresh material of existence. It is the newly minted volume created by the growth of our horizon. The void is not empty. It is the expanding body of the universe adjusting to its new mass. There is something strangely intimate about this connection. It suggests that our universe is not a closed, isolated box that is slowly running down. It is an open system. We are receiving energy and information from the outside. We are part of a flow. Just as a cell in your body receives nutrients from your bloodstream, our cosmos receives nutrients in the form of mass from the parent universe. We are being sustained. This might explain why dark energy is so incredibly smooth. One of the puzzles of this force is that it doesn't clump. Gravity makes things clump. It pulls matter into stars and planets. But dark energy is perfectly uniform. It is the same everywhere you look, in every direction, billions of light years away. This uniformity makes perfect sense if it is a property of the boundary. If the shell of the balloon expands, the air inside expands uniformly. It doesn't stretch more in one corner than another. The growth of the event horizon is a global event, and so the expansion of our interior is a global experience. Let us take a moment to consider the scale of this. If the density of our universe matches the density of a black hole, then the math suggests a linear relationship between the size of the universe and its mass. This is a specific prediction, and recently, scientists looking at the growth of black holes within our own universe have found hints of this same coupling. When astronomers measure ancient black holes, those formed billions of years ago, they often find them to be much larger than expected. They seem to have grown too fast, faster than they could have by simply eating stars. Some researchers have proposed that these black holes are growing because the universe itself is expanding. They are coupled to the stretching of space. If this is true for the black holes inside our universe, it stands to reason it is true for the black hole that is our universe. It is a nested system of growth, like a set of gears turning within gears. This reframes the terrifying concept of the Big Rip. In traditional cosmology, the acceleration of the universe is a doomsday scenario. If dark energy keeps pushing harder and harder, eventually it will tear galaxies apart, then solar systems, then atoms, until everything is ripped into a cold, lonely nothingness. It is a bleak ending, but in the black hole scenario, expansion is not a tear, it is an accommodation. A black hole can grow forever without ripping apart its interior. As long as matter falls in from the outside, the inside grows. We are simply becoming a larger universe. The distance between galaxies increases, yes, but the galaxies themselves remain bound by their own local gravity. We are safe in our local clusters, floating in a growing ocean. The universe is not dying. It is maturing. It is getting bigger, older, and perhaps wiser. Let us pause and reflect on the feeling of this expansion. We often feel that the universe is indifferent to us, a chaotic explosion fading into the dark. But if this theory holds, the universe is actually a thriving, growing entity. The force that separates the galaxies is the same force that signifies our survival. If the parent black hole were to evaporate, to lose mass, our universe would shrink. The fact that we are expanding means our container is stable and active. What is it that is falling into our parent black hole? Is it just hydrogen gas? Or could it be something more complex? If the parent universe is as rich and diverse as ours, perhaps entire stars, planets, and even light from alien civilizations are crossing our event horizon. As they pass through the scrambler of the boundary, their physical form is lost, but their energy is added to our world. We are built from the recycled possibilities of another dimension. This brings us back to the idea of the vacuum. In quantum physics, empty space is not empty. It is seething with virtual particles popping in and out of existence. It has energy. We call this the zero-point energy. For a long time, physicists have tried to calculate the value of this energy, but their calculations are wildly off by a factor of 120 orders of magnitude when compared to the dark energy we actually see. This is the worst prediction in the history of physics. But if we are inside a black hole, the calculation changes. We shouldn't be adding up all the quantum vibrations in the volume. We should be looking at the surface. The energy of the universe is defined by the horizon. When you do the math that way, the numbers start to align. The amount of dark energy we see matches the energy expected for a holographic universe of this size. The expansion is simply the system seeking equilibrium. As we drift through the dark, expanding sectors of space, we can stop seeing dark energy as a ghost. Instead, see it as the breath of the cosmos. Inhale. The event horizon expands, the galaxies drift apart. Space opens up, creating new room for new possibilities. It is a slow, rhythmic breathing that happens over billions of years. We are living inside a lung that is drawing in the substance of a greater reality. This perspective also invites us to wonder about the future. If our universe is a growing black hole, is there a limit? Will we ever stop expanding? In the parent universe, a black hole can eventually consume all the matter in its vicinity. It clears its dinner plate. When that happens, the accretion stops. The black hole settles into a quiet, dormant state. If that happens to our parent, our expansion will slow and stop. The universe will become a fixed size, a steady-state cosmos where the galaxies hang in suspension. We would no longer look out and see a runaway world. We would see a calm, unchanging sky. Perhaps that is the ultimate destiny of our home, to grow until it is full, and then to rest. But for now, the feeding continues. The acceleration we measure tells us that the parent black hole is active. It is eating, and so we are stretching. There is a profound lesson here about our perception of forces. We feel the pull of gravity and the push of dark energy as two opposing armies fighting for the soul of the universe. Gravity wants to crush. Dark energy wants to tear. But in this unified theory, they are not enemies. They are partners. Gravity is the geometry of the container holding us together. Dark energy is the geometry of the container growing larger. They are the yin and yang of a living geometry. One defines our shape, the other defines our scale. As we conclude this section of our journey, floating in the expanding silence, we are left with a sense of infinite nesting. If we are inside a black hole, and that black hole is growing by eating matter from a parent universe, does the chain stop there? Is the parent universe also inside a black hole? Is there a grandparent universe? We have looked up at the stars and realized they might be the reproductive organs of the cosmos. We have looked at the darkness and realized it might be the expanding interior of a giant shell. Now, we must take the final step. We must look at the structure of the whole. We must ask if the universe is a fractal, a shape that repeats itself endlessly, up and down, forever. Are we living in an infinite tower of Russian dolls? And if so, are we near the top, the bottom, or are we simply lost in the beautiful middle of forever? Let us prepare to open the final door and gaze into the abyss of the infinite. We have traveled far tonight. We have drifted from the silent, invisible edge of the event horizon to the fiery, explosive birth of the Big Bang. We have touched the shimmering, holographic walls of our reality and watched as the unseen breath of a parent universe expanded the space between our galaxies. We have considered the possibility that our laws of physics are not random accidents, but the hard-won inheritance of a cosmic lineage honed by eons of natural selection. Now, as we reach the final stage of our journey, we must pull back even further. We must widen our lens until the universe we know, with all its billions of light years of dust and fire, becomes just a single speck of light in a much larger darkness. If we accept the premise that our universe exists inside a black hole, and that black holes in our universe might contain other universes, we are immediately confronted with a dizzying geometry. It is the geometry of the infinite nest. It is the structure of the Russian Matryoshka doll, where opening one shell reveals another, identical but smaller, hidden within, and inside that one, another and another, down and down into the microscopic depths. But the chain also goes up. If we are inside a black hole, that black hole sits in a galaxy and a parent universe. But is that parent universe floating freely? Or is it too trapped inside the event horizon of an even larger black hole? Is there a grandparent universe? A great-grandparent? As we cast our minds upward, scaling the ladder of dimensions, we see no logical reason for the pattern to stop. We might be living in an infinite tower of universes, a cascading waterfall of realities tumbling into one another forever. This concept is known as the fractal cosmos. In mathematics, a fractal is a shape that looks the same at any scale. If you look at the coastline of Britain from a satellite, it is jagged and winding. If you zoom in on a single bay, it is jagged and winding in the same way. If you zoom in on a single rock, the pattern repeats. Nature loves fractals. We see them in the branching of trees, in the veins of leaves, in the lightning that cracks the sky, and in the blood vessels of the human lung. It is the most efficient way to organize complexity. Why should the universe be any different? For centuries, alchemists and philosophers whispered the maxim, "As above, so below." They believed that the microcosm of the atom reflected the macrocosm of the solar system. For a long time, modern science dismissed this as poetic wishful thinking. Atoms, governed by quantum mechanics, behave very differently from planets governed by gravity. But the black hole theory brings this poetry back into the realm of physics. It suggests that while the mechanics might differ, the structure is indeed a repeating echo. When we look through our telescopes at the black hole in the center of the Milky Way, Sagittarius AO, we are looking at a dark sphere, millions of kilometers wide. We see gas clouds swirling around it. We see light bending. But if this theory holds, we are also looking at the exterior of a universe. Inside that dark sphere, beyond the veil of the horizon, there might be another Big Bang happening right now. There might be galaxies forming, stars igniting, and perhaps, on a small rocky world, a creature looking up at its own dark sky, wondering where it came from. To that creature, our massive black hole is their entire cosmos. And to us, their entire cosmos is just a small, dense, heavy object sitting in the constellation of Sagittarius. It is a matter of perspective. It is a matter of scale. This realization brings a profound sense of vertigo. It forces us to question the definitions of big and small. In this fractal tower, size is relative. To a universe inside a proton-sized black hole, we are titans, unimaginably vast, spanning dimensions they cannot comprehend. But to the observer in the universe above us, the one looking at the black hole we live in, we are subatomic. Our entire history, from the Big Bang to the present moment, might be a fleeting quantum fluctuation in their laboratory experiment. This vertigo, however, gives way to a strange sense of belonging. If the universe is infinite in both directions, up toward the giants and down toward the atoms, then there is no center. There is no edge. There is no top or bottom to reality. We are simply part of the chain. We are a link. We are both the child of a greater reality and the mother of lesser ones. We are the middle children of eternity. Let us imagine for a moment the journey of matter through this infinite cascade. Imagine a single atom of hydrogen floating in our parent universe. It drifts through the void for eons until it is caught by the gravity of the black hole that is our home. It spirals in, crosses the horizon, and is torn apart, its energy feeding the expansion of our space. It becomes part of a nebula in our Milky Way. It collapses into a star. That star lives, burns, and eventually dies, collapsing into a new black hole. Now that same energy, which was once hydrogen in the parent universe, then starlight in ours, falls into the new black hole. It becomes the seed for a baby universe below us. It explodes into a new Big Bang, becoming hydrogen once again in a new dimension. Matter is never destroyed. It is simply translated. It flows through the sieve of the event horizons, changing form, changing scale, but always persisting. It suggests a kind of cosmic reincarnation. The substance of your body may have once been the substance of a star in a higher realm, and one day it may form the building blocks of life in a lower one. We are travelers on a river that flows through the heart of suns. This view also softens the terrifying isolation of the heat death. Cosmologists tell us that eventually our stars will burn out. The galaxies will drift so far apart they will disappear. The universe will grow cold and dark. In the Standard Model, this is the end of the story, a graveyard of entropy. But in the fractal black hole model, this death is merely a phase. Even as our universe grows cold, the black holes within it are thriving. They are the lifeboats. As our visible universe fades, the energy is not lost. It is being funneled into the interiors of the black holes we created. The life of the cosmos moves down the ladder. Just as a dying tree feeds the saplings beneath it, a dying universe feeds the baby universes within it. The light goes out in the attic, but the party continues in the basement. And the basement has a basement. The flame of existence is passed down the chain, never truly extinguished, only hidden from view. There is a question that naturally arises from this nesting. Is there a bottom? Is there a smallest possible universe? Current physics suggests there is a limit to smallness, the Planck length. Below this scale, the concept of distance ceases to make sense. But if a universe inside a black hole has its own laws of physics, perhaps its Planck length is smaller than ours. Perhaps the scale shrinks with every generation. What we consider the bottom of physics might be the expansive sky of the next level down. The concept of infinite is difficult for the human mind to hold, but the math of fractals allows for it. You can zoom into a Mandelbrot set forever and never run out of complexity. Reality might be the same. And is there a top? Is there a prime universe that started it all? Or does the chain go up forever too? It is possible that the multiverse is a loop. Perhaps in some twist of higher dimensional geometry that we cannot visualize, the bottom of the chain feeds back into the top. Perhaps the smallest universe eventually becomes the seed for the largest. It sounds impossible, like a snake eating its own tail, but the Ouroboros has always been the symbol of the cosmos for a reason. In a world where space curves and time bends, the beginning and the end often touch. As we drift toward the end of this documentary, let us bring our focus back to the here and now, back to the feeling of lying in the dark, safe and warm. The idea that we live inside a black hole might sound frightening at first. It sounds like a trap. It sounds like a prison. But think of what a black hole actually is. It is a protective shell. It is a barrier that separates the inside from the chaos of the outside. Inside the event horizon, space is allowed to expand. Time is allowed to flow forward. order is allowed to emerge. If we were exposed to the raw, higher dimensional bulk of the true multiverse, perhaps we could not exist. The forces might be too wild, the radiation too intense. The black hole is a womb. It provides the stability needed for delicate things, like atoms, molecules, and minds, to grow. We are shielded by the gravity of our container. We are held in the embrace of a singularity that pulls us toward the future. This theory transforms the night sky. When you look up at the darkness between the stars, you are not looking at emptiness. You are looking at the body of the black hole that sustains us. You are looking at the mechanism of your own existence. The darkness is not a void, it is a wall, but a wall so vast and so distant that it looks like infinity. And when you close your eyes tonight, you can feel the subtle pull of that geometry. You can feel the gravity that anchors you to the Earth, which orbits the Sun, which orbits the galaxy, which drifts in the expanding interior of a cosmic giant. You are safe in the nesting. You are held by layers upon layers of space-time, wrapped in the blanket of the universe. There is a peace in being small. We do not have to carry the weight of the entire infinite tower. We only have to live in our section of it. We only have to play our part in the ongoing story of creation. We are the observers. We are the universe's way of knowing that it is inside a black hole. Without us, without our eyes and our minds, the process would happen in the dark. We bring the light of awareness to the mechanism. So, as you drift into sleep, let the boundaries dissolve. The walls of your room are just projections. The silence of the night is the silence of the event horizon. You are not separate from the cosmos. You are woven into its deepest, strangest architecture. You are a child of the singularity, a traveler in the hologram, a citizen of the fractal infinite. We are drifting now, carried by the gentle expansion of the dark. The stars are our companions, the black holes are our windows, and the night is our home. The universe is vast, mysterious, and endless, but it is also intimate. It is all around you. It is inside you, and it is holding you. Good night.